Hi everyone. So this video is in continuation with our discussion on the preparation of alcohols, and in this video we are going to discuss the preparation of alcohols from the alkyl halides. Okay, as we know, the alkyl halides are the organic compounds in with the general formula Rx. Okay, so R is the alkyl group. It can be any alkyl group, and X is the halide. Okay, this is the halide which can be this halide can be a chlorine, it can be a bromine or an iodine. Okay, and R can be any what you call as alkyl group. So this is a CX bond actually. So we call this class of compounds, organic compounds, as alkyl halides. So these alkyl halides can be used for the preparation of alcohols. Okay, so first reaction for the preparation of alcohols from the alkyl halides is the so alkyl halides can be converted to the alcohols by using water or hydroxide as the nucleophile. Okay, we use water or the hydroxide as a nucleophile in the reaction. So actually from water or the hydroxide, what we are getting a nucleophile, and the nucleophile in this case will be hydroxide and OH negative. Okay, that will attack the alkyl group. Okay, and it will kick off this halide and will substitute itself to with the alkyl group, and will be getting the corresponding alcohol. Okay, this is a general example of the reaction, and this is a particular example in this case. So this is actually chloropropene, chloro not propene, chloropropane. Okay, this is a chloropropane, and we are getting from this propanol. This is propanol. Okay, so this general representation of the reaction, simple example here. Okay, so if we talk about some key points of the reaction, this is a nucleophilic substitution reaction. Okay, the reaction type, that is the hydrolysis of alkyl halides, is the nucleophilic substitution reaction. And in this reaction, the reagents are aqueous hydroxide ion, sodium hydroxide, and or we can use also potassium hydroxide. Okay, these actually provide us this nucleophile, that is OH negative, but it is in the aqueous medium. Okay, so the mechanism of the reaction is the nucleophilic substitution reaction, and it can follow two types. We have two types of nucleophilic substitution reactions. It can be SN1 reaction or SN2 reaction, depending upon the substrate and the conditions of the reaction. The reaction can follow any of these two nucleophilic substitution reactions. We are not going to discuss the mechanism of this reaction at this point, because this needs a little bit detail. This will be discussed in detail in the coming videos. Okay, so this is not actually a good method of preparing alcohol. It's not particularly used, and it's not a common method, because actually we use alcohols for the preparation of alkyl halides. Okay, so this is not the key reaction that we use for the preparation of alcohols, but the reaction is there. Okay, so the next is actually the important one, that is we can prepare alcohols from the Grignard reagents. Okay, so what is here to do with the alkyl halides we'll be discussing. So Grignard reagents are actually what? Grignard reagents are actually the organometallic reagents. Okay, with the general formula RMgX. Okay, this is the organometallic reagent. What does organometallic mean? In organometallic reagents, there is a carbon metal bond. Okay, carbon metal bond. Here we have this alkyl group, it provides the carbon, and this is the metal, this is bond between the carbon and metal. So we call such compounds, that's carbon metal compounds, in which we have a bond between carbon is bonded to the metal, we call them as organometallic reagents. Okay, so Grignard reagent is one of the organometallic reagents. We have other examples of organometallic reagents, but Grignard reagent is one of them. And in Grignard reagent, we have an alkyl group that is attached to magnesium. This is a metal, and a halide ion is attached to the magnesium. Okay, so we call it as the organometallic reagent. And this is the Grignard reagent. This is particular name for this reagent, that is Grignard reagent. Okay, this is the Grignard reagent. Now, actually, these Grignard reagents are made from the alkyl halides. Grignard reagents are made by adding haloalkane to small bits of magnesium in a flask containing ethoxyethane, which we call as ether. Okay, in the presence of ether, we are reacting. We react haloalkane or alkyl halide. Other name for the alkyl halide is haloalkane. Okay, when we react this alkyl halide with the magnesium in as a result in the, but this is in presence of the ether, and this should be dry ether. Okay, there should be no content of water in this, and as a result this this metal is inserted into the carbon halide bond, and we're getting the Grignard reagents. That's why we have included we have included this reaction into the reaction of alkyl halides. Actually, alkyl halide is a precursor for the formation of what you call as Grignard reagent. Okay, from alkyl halides we are preparing the Grignard reagent. Okay, in many books you will find this reaction as separately, so we have included it here. We should understand the thing. Now let's look how we can prepare the we can prepare the alcohols from the Grignard reagent. Actually, aldehydes and ketones are used as substrates which react with the Grignard reagent and produce alcohols. Okay, here is a simple example with mechanism. We have taken this is an aldehyde and we call it as methanol. Okay, this is methanol, or what you call as formaldehyde. This is methanol IUPAC name is methanol, or commonly we call it as formaldehyde, in which this carbon is attached to two this carbonyl is attached to two hydrogens. Okay, and again, as we already know, this carbonyl group is polar. This is polar in nature. Okay, so there is a small positive charge on this carbonyl carbon and small negative charge on the oxygen. So it's a polar bond. Again, the bond between the carbon and the magnesium in the Grignard reagent is again polar, because this carbon is attached to the metal. This is attached to metal, and this is more electronegative than carbon. As a result, the electron density is more towards the magnesium, more towards the magnesium, and there is a negative charge on the carbon and positive charge on the magnesium. As a result, now there is a nucleophilic attack of this reaction on this electrophilic carbonyl carbon. Okay, so the reaction takes place in the dry ether. There is the shift of this pi bond towards the oxygen, and as a result we are getting this metal complex. Okay, this is metal alkoxide complex, and simple acid base reaction here. The oxygen, because again this is having a negative charge, this is having the positive charge. Now the oxygen will take the proton from the reaction medium. We are taking water and adding small acid to the water. As a result, the proton will be taken by this oxygen, and we are getting the corresponding alcohol in this case. Okay, so this is the alcohol, and there will be one hydroxyl group will be attached to the magnesium. Okay, this will come as a byproduct in the reaction, and this will be our alcohol. Okay, and the type of alcohol here we are getting is the primary alcohol. This is the primary alcohol, 1 degree alcohol. Okay, so the reaction of methanol with the Grignard reagent gives us the primary alcohol. Okay, we can take another example here. So now we have taken we have taken an aldehyde. This is an aldehyde. Okay, if we try to name this is methanaldehyde. Okay, this is methanaldehyde. Again, this is polar bond, and carbon magnesium is again a polar bond, and same reaction is going to occur here. Again, the same attack of this negatively charged carbon on the carbonyl carbon, and same metal alkoxide complex is formed, and again same acid base reaction taking place, and we are getting the alcohol in this case. And if you look at in this reaction, we are getting a what you call as the 2 degree alcohol, secondary alcohol. So from the reaction between an aldehyde and the Grignard reagent, we are getting secondary alcohol. Okay, we are getting secondary alcohol, and this is the byproduct in the reaction. And if we take another example, this is an example of ketone. Now we are reacting ketone with the Grignard reagent. Look, we have taken a different Grignard reagent here. Okay, Grignard reagent's general formula is RMGX, as we already told. And this R can be anything. This can be a cyclic alkyl group. This can be a branch chain. This can be a straight chain. This can be anything. This can be methane, ethane, propane, butane. So in this case, we have taken the okay. This is the ethyl group that is attached to the MgX. And particularly we are taking bromine, okay, as X in these cases. So here's the reaction of Grignard reagent with this ketone, and again same thing is happening. But here we have to keep in mind that now this carbon will attack on the positive charge of the carbonyl carbon, because this will be having more del negative charge as compared to this carbon. Okay, so this is going to attack on the carbonyl carbon, and in the presence of dry ether, this is reaction is going to happen. And all the mechanism, as we have seen in the previous reactions, everything is going same, and we are getting an alcohol in this case. And if you notice the thing here, we are getting 1, 2 and 3. This is tertiary alcohol, 3-degree alcohol. In this case, this is 3-degree. So from the reaction between the ketone and the Grignard reagent, we are getting tertiary alcohol. So this is a simple mechanism of the reaction between Grignard reagent and the ketone and the aldehydes and ketones, okay, in which we are getting alcohol as the product. We can get a wide variety of questions from this reaction, okay. But all of them are following the same mechanism, and they are easy to follow, okay. So um, we can just conclude that reaction with formaldehyde, that is the methanol, gives the primary alcohol. These points are to be kept in the mind, okay, because they will help a lot in solving the problems. So reaction with the other aldehydes produce, because methanaldehyde or formaldehyde, what you call it, this is also methanol or methan from formaldehyde. This is also an aldehyde, okay. This produce the primary alcohol, others give us the secondary alcohol. And if we react, reaction with ketones produce the tertiary alcohol, and the reaction is the reaction of the alkyl halides, of the ketones, or what you call as the aldehydes, is with the Grignard reagent. Okay, so this gives us these types of alcohols. So let us look at few examples here. This is the example number 1, and we have been given a substrate. This is an alkyl halide, okay. This is what you call as bromopropane. This is bromopropane, okay. And we have the reagents. First we have magnesium, and this is the solvent as ether. Second reagent is, this is the what you call as formaldehyde, and we have the third reagent is water in presence of the acid, and we have to give the product of this reaction. So first of all, we'll look at this substrate. This is alkyl halide, and in the first step we have been given with the magnesium and ether. And we know when alkyl halide and the magnesium in presence of in the ether as solvent is reacted, we get the Grignard reagent. So in the first step of this reaction, we'll be getting the Grignard reagent, okay. We'll be getting the Grignard reagent. So the Grignard reagent that we'll be getting in this reaction will be, this is Mg, and this will be the Br, okay. So this is the Grignard reagent that will be getting in the first step of this reaction, okay. Then we have to react this Grignard reagent with our second reagent, that is actually a substrate itself, which is a formaldehyde, okay. And we know when we react formaldehyde and the Grignard reagent, we get primary alcohol, okay. And we get primary alcohol, and third reagent is the acidic workup. So the product in this reaction, as we know, the overall transformation will be the formation of the OH bond at this carbon, okay. This will be OH bond here, and there will be the attachment of a alkyl group at this carbon. So we'll be getting COH. This is the alcoholic group, this is the CH, and to this carbon will be attached the alkyl group, and the alkyl group in this case will be this part of the Grignard reagent, okay. So this is CH2 CH3. So this will be the this will be the product of the reaction. Okay, so most of time we get the question like this. We have been given the raw substrate and we have to look at the formation of the Grignard reagent first, and then only we can react it with the given aldehyde or the ketone. Okay, so let's look at the similar examples. We have been given an example. This is an aldehyde. Okay, this is methanaldehyde. So we are reacting it with the Grignard reagent and acidic workup. Okay, this is a simple reaction, nothing to think about. We have to make an alcohol, so it will be CH3 COH at this position and H as it is, and to this carbon will be attaching this part of the Grignard reagent, that is CH3. Okay, now this is the 2-degree alcohol that have been formed. Another example, this is a ketone. Okay, now this is a ketone in this reaction and we are reacting it with the Grignard reagent. Okay, these are different forms of Grignard reagent. Okay, different forms of the Grignard reagent that I have added a variety of Grignard reagents for the clearance. Okay, so what we'll be getting, we'll be getting this bond will be made OH. Okay, and rest will be like as it is C2H5 at this position, and to this carbon will be adding this part of this alkyl part of the Grignard reagent. So it will be, we can simply write it as C2H5. Okay, or CH3 or C2 CH2 CH3 can be also written. Okay, so this will be the product. These are some simple examples that we have solved here. In the next sections we'll be looking some other methods of preparation of alcohols.